Okay, we are starting topic 6. Please everyone turn your books to page 127. We're going to start systems of linear equations. So what is a system of linear equations? Well, a system just means more than one. And linear, of course, means line. So the first thing we want to do is just kind of picture what this is. I'm going to show you some pictures. So here's one. Here's a system of linear equations because we have two lines on a graph. Where they cross, that's our solution. In this case, they cross at 4, 2. So our solution would be at 4, 2. Here's another example of two lines. Remember, it's just more than one line. And here is where they cross. And they tell us the solution in this picture is at 2, 1. We can compare it to one equation, two equations. Now a system means more than one, so is it possible to have 3 equations? Yeah. And they have varying solutions all around where they meet. Last one, we have 3 linear equations on one graph, and these all have the same solution. They tell us here that this solution is at 1, 1. Now remember, solution just means where they cross. So, back to our first page. We are talking about two friends running a race, and runner 2 waits 4 seconds before starting. Runner 1 starts at the starting, but runner 1 obviously is slower. The question is, will these runners ever pass each other? So I'm kind of going to make a little table here, and we have runner 1 and we have runner 2. And let's put our seconds on this table. So we have 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, 7 seconds, 8 seconds. So 1 second, runner 1 has gone 4 yards. Runner 2 hasn't even started yet. Remember, runner 2 waits 4 seconds. It says it right here. At 2 seconds, runner 1 has gone 8 yards. 2 still hasn't started. We're at 12 yards. Hasn't started. We are at 16 yards. Still hasn't started. 5 seconds is pivotal. Runner 2 has gone 8 yards. Runner 1, 20. 6 seconds. Runner 1, 24. Runner 2, 16. So, again, we're at 16. Runner 1, 28. Here we're at. Oh yeah, that was right, 24. 1 second later, 32, and oh look, runner 2 finally caught runner 1 at 8 seconds. So this is kind of like their solution. If you imagine these two runners as lines, right, runner 2 is going much steeper than runner 1, they would pass each other at 8 seconds or 32 yards. Let's go ahead and flip our page. Which of the following expresses a system of linear equations? Well, number 1 is only one equation. Number 2, we have 2 equations in a system. Number 3, we have 2 equations in a system. Some notes you want to make here. If you ever see an exponent, so let's say you see y equals x squared. Let me redo that. Y equals x squared. This is not a linear equation. So these are all no's right here. We're going to say no's. Okay. Also, you can't have anything where maybe there's an x times a z. So anything where 2 variables are multiplied is not a linear equation. We want to mainly look for y equals mx plus b in these, or y equals mx, or even an x equals. Those all fall under the linear equations. Okay, so what I would like you to do now is pause the video and try page 130, number 1. Pause the video and try it on your own. And I will go ahead and give you the answer. So right off the bat, we see our system here. And then that's actually our only one. Because if we see B here, they try to get us with 2 equations. But remember, we can't have 2 variables multiplied together. All right, let's flip back to page 128. This time we're checking to see if a point is a solution to the system. Now remember, a solution means where they cross. We're trying to figure out if 3 comma negative 4 is the solution to this system of linear equations. And I'm going to kind of color code these. So our x is 3, and I'm going to be putting in 3 for x here. Our y is negative 4. I'm going to be substituting in negative 4 for y. So I'm going to just see if these check out. So we have 3, and instead of writing x, I'm going to write 3. And then we have plus our y. And instead of writing y, I'm going to write negative 4. And we want to check if that does in fact equal that negative 5. Well, we got 3 times 3, that's 9, plus negative 4. Does that equal 5? Yes, it does. I like to say, yeah, it's a smiley face there. Now let's try this one. I'm going to do this work over here. X minus y equals 7. So does, and remember we're color coding, instead of writing x, we're going to write 3, minus, instead of writing y, we're going to write negative 4. Does that equal 7? Well, yes, in fact it does. 3 minus negative 4 does equal 7. 7 equals 7, yes. Since it checks out for both, this is a solution. So how you put this, 3 comma negative 4 is a solution. This is the only solution to the system. This is exactly where they cross. Let's go ahead and split that page in half, and I want to try another example here. This time our x, which is blue, is 2, our y is 4. So some of us might even get into the habit of just writing this right above. So look, we have 2 minus 4. Does that equal negative 1? Oh, and this one's pretty easy. 2 minus 4. No, that doesn't equal negative 1. That equals negative 2. So right off the bat, we don't even have to check this one. We already know that it's not true. So 2 comma 4 is not a solution. Because why? Because it doesn't check out of this first equation. Therefore, it's not a solution. Now, it's not to say that these two lines won't cross each other. Somewhere they will, but it's not at the point right here, 2 comma 4. Okay, so again, I want you to pause here, go to page 130, pause the video, and do number 2. Pause the video and do number 2. Try it on your own. Okay, and our answer for number 2, there's one answer, and it is only 6 comma 6. You should have tested each of these in and see if you got the right answer. All right, flip back. We have these things called Greenland sharks and spiny dogfish sharks. And I like to circle these like this. And we're going to write our system of equations. The cool thing about this is in y equals mx plus b, which we love, and it only wants our equations. We don't have to graph these. So if we're looking at our Greenland shark, its initial length is 37, and its growth is 0.75 per year. That means that per gets, go ahead and pair that up with our x, and it's going to be added to our initial length. Now here we have y equals our initial length, and our per, we got 1.5x plus 22. Which one's growing faster? The spiny dogfish. All right, now you are going to try this on your own. Remember, circle it up this way and just write the equations. You do not have to graph anything. Pause it and try it on your own. Okay, your answer should have been apple, y equals 1.2x plus 2.75, and cherry, y equals 1.38x plus 2.12. Please now go ahead and log into Digits and start your homework. It is due Tuesday.